Have you ever really stopped to think about your arm? I mean, really think about it. It's not just a limb. It's a perfectly calibrated piece of biological machinery. Today, we're going to take a tour, from your shoulder all the way to your fingertips to uncover the brilliant design that's hidden right under your skin. So let's get into it. So what is it? Just an arm or something way, way more? You know, by the end of this, I'm willing to bet you'll see something as simple as lifting a cup of coffee in a completely new light. Let's break down the blueprint of this incredible structure. Every single powerful movement, every precise little action you make, it all starts right here, at the shoulder. This is our home base, the foundational anchor point for everything else. Because without a stable base to work from, none of the cool stuff we'll talk about later would even be possible. Okay, let's kick things off with a classic, the bicep curl. When you flex that muscle and you see it bulge, where do you think that power is really coming from? I'll give you a hint. It's not just from the part you can see. The true starting point is much, much smaller and way more specific. And there it is, the supraglenoid tubercle. It sounds complicated, but it's really just a tiny little spot on your shoulder blade. But that tiny spot is the critical anchor for the main tendon of your bicep. It's a perfect example of how a huge, powerful muscle depends entirely on a very small, very precise connection to do its job. So let's check out the whole neighborhood. Your bicep actually has two parts, or heads. We just meant the long head. The other one, the short head, attaches just nearby. And get this, right below where the bicep attaches, that's where its opposite muscle, the triceps, hooks in. It's this incredibly organized system of push and pull forces, all starting from the very same bone. Okay, so we've talked about pulling, but what about pushing? Just imagine you're leaning your whole body into a really heavy door. What muscle do you think is actually doing the hard work of moving your shoulder blade forward to give you that extra power? The answer? It's the serratus anterior. This muscle is so cool. It literally wraps around your ribcage like a set of fingers and grabs hold of your shoulder blade. When it pulls, it brings the whole shoulder blade forward and around your body. That motion is called protraction, and it is the absolute key to any strong push or reach you make. The main thing to get here is that each muscle around your shoulder blade is a specialist. The serratus anterior is your pusher. Its direct counterpart, the rhomboid major, is your puller. The levator scapulae is the lifter. And then you've got the big trapezius muscle, which kind of does a little bit of everything. It's a whole team of specialists working together. All right, we've set up our anchors. Now let's look at the infrastructure. We're talking about the vital highways, the nerves carrying the commands, and the arteries supplying the fuel that have to run the entire length of the arm. Now, deep inside your shoulder, the body has built these careful tunnels and gateways for all this important traffic. One of the most critical is the quadrangular space. It's a pretty small opening, but what passes through it is absolutely essential for your shoulder to work right. And this is what's at stake. Two things make the trip through this little space. The axillary nerve, which is the one and only power supply to your main shoulder muscle, the deltoid, and the artery that feeds it. So you can imagine, any damage to this tiny space can cause some really big problems. You know, in anatomy, it's all about location, location, location. Right next to the quadrangular space is another little opening, the triangular interval. And a completely different nerve, the radial nerve, uses that passageway to get down the back of the arm. The body literally engineers these separate, protected expressways for our most vital structures. It's brilliant. Okay, now let's follow the fuel supply. The main pipeline for blood in the arm is the brachial artery. As it gets down past the elbow, it hits a fork in the road and splits into two new highways, the radial and the ulnar arteries. From there, they travel down either side of your forearm, making a beeline for your hand. So where do they go? Well, they actually meet up again, in the hand, to form these two amazing loops, or arches. The ulnar artery is the main player for the superficial arch, the one closer to the skin. But it's the radial artery that's the primary source for the deep palmar arch. And that's the one that supplies all those tiny, precise muscles deep inside your hand. And that brings us to our final destination, the hand itself. This is where all that power from the shoulder and all that fuel from the arteries comes together in this incredibly intricate network. A network that allows for amazing precision, but, as we're about to see, also has its perils. I'm pretty sure you've heard of carpal tunnel syndrome. It's a perfect, if pretty painful, example of this whole precision versus peril idea.
The entire condition just boils down to one critical nerve getting squeezed in a very, very tight space at the rest.
So, just how crowded is it in there? Well, this gives you a pretty clear idea. Passing through this one narrow tunnel, you have 9 separate tendons that are all working to bend your fingers and thumb. And squeezed right in the middle of all of them is the soft, squishy median nerve. There is absolutely no extra room in there. This quote really says it all, doesn't it? That nerve is not traveling solo. It's stuck navigating a traffic jam with 9 other busy commuters. So if any of those surrounding tendons get even a little bit inflamed or swollen, they immediately start putting pressure on that vulnerable nerve right next to that. And this chart just puts it all in perspective. The median nerve is at high risk precisely because it's stuck inside that super crowded carpal tunnel. The ulnar nerve, which has its own little tunnel, is at a moderate risk. But the radial nerve? It doesn't even pass through a tight tunnel at the wrist, which is why its risk of getting compressed like this is so low. So as we wrap up our tour, it's pretty clear that the arm isn't just a random collection of parts. It's a fully integrated system. The stability of the shoulder directly affects the protected pathways in the arm, which in turn allows for the absolutely incredible function of the hand. It's all connected. So what are the big takeaways from our journey? First, all that power we have starts at these tiny, precise anchor points in the shoulder. Second, the body is a genius at creating protected channels for its vital nerves and arteries. And finally, the incredible complexity of our hands is what gives us fine motor skills, but it's also what creates potential weak spots, like the carpal tunnel. We've explored the incredible engineering of your arm, from its powerful anchors all the way down to its delicate wiring. So the final question isn't for me, it's for you. Now that you understand the blueprint, how are you going to maintain and protect this masterpiece?